100-301 is the new CCNA exam that was released back in February. This is going to cover basically how the OSI model and the TCIP model are related and what they actually mean. So if you've never heard of either of these, that's okay, because this is who this video is for, people who have never heard of either of these. So the first thing we're going to look at is the TCP IP model. And as you can see, it's broken down into 5 different layers. The first layer is physical, second data link, third network, fourth transport, and the fifth application. So for networking, we really don't deal with too many things in the application window, in the application layer. Most of the stuff we deal with will be done with between layers 1 to layer 4. So the first layer, the physical layer, is pretty straightforward. It is what actually connects your network to whatever you're trying to connect to, whether it's Wi-Fi or if it's a wireless wired connection using copper cables, or if you're using fiber. It's just the physical way you're getting your data. So that's pretty straightforward. Next comes data link layer. So data link is layer 2, and it operates using switches. So you've probably heard of a router, but you might not have heard of a switch. A switch is basically what forwards data using MAC addresses. So your MAC address is a hardware address that's assigned to every single device, and they're all unique. If you go into your phone and go into your About Phone settings, you might be able to see it. If on an iPhone, I think it's called a Wi-Fi address, but on an Android, it may be called a hardware address or a burned-in address. It might even just say MAC address. There's a lot of different names for it, but MAC address is what we're going to be using for our learning. This also uses frames to transmit data. I know this all might sound kind of weird out there right now, but it makes more sense over time. This is just getting you introduced to the actual terminology. But frames are how data is transmitted over layer 2. Another name for frames is L2 PDU. That just stands for Layer 2 Protocol Data Unit. So that's another name for a frame. It's how the data is transmitted. So you'll have a MAC address, which is used for your source and destination. So if you're trying to connect to your PC, your PC will have a MAC address, and a switch will forward to your computer by your MAC address. It'll look up your MAC address in its MAC address table, and then it'll forward it to you. Next thing is the network layer. So network layer might be a little bit more familiar. You've probably heard of a router, and you've probably heard of an IP address. And you might have even heard of packets. So packets are basically how data is transmitted on layer 3, also called a layer 3 protocol data unit. It's just the same as layer 2, just they popped into the 3 instead of the 2. So packets will basically route data based on your IP address, and then once it gets the right information, it'll send it to your router, and then your router your home router is actually a combination of a switch and a router. So your router will get the information, then it goes to the switch part of your router and will send it to your MAC address. So your IP address isn't actually the address that's used to get directly to you. It uses your MAC address. The next thing is the transport layer. So transport layer we're not going to go too in depth with. You just need to know that there are 2 types of protocols in the transport layer: TCP and UDP. TCP is considered a connection-oriented protocol, which basically means if you're trying to send data to somebody, it'll first send out a message saying, it's called a sync, saying, hey, I'm going to talk to you. After you receive that sync, you will send a confirmation back, basically saying it's a sync acknowledge, saying, hey, I got your sync notification, I'm ready for the data. And then the third one will send out one more final data saying, okay, or one more final synchronization saying, alright, here comes the data, and it'll send the data. And anytime data is dropped, it's ordered with TCP. So anytime it notices that, hey, I missed something, it'll resend it with TCP. So this is used for like file transfers and things like that. But if you look at UDP, it's connectionless, and this is used for things like video. So on YouTube, if you ever go in and it's buffering, or some data, or the video cuts out a little bit but it still keeps playing, that's because it's using UDP data. It doesn't really care if a couple frames or a couple packets are dropped here and there. It's just going to continually send that out there. So TCP and UDP are transport, and then application is basically the rest. So as you can see on the other side, there are a couple more layers. There's session, presentation, and application. That's because the OSI model is an older model, and we've moved away from that, moved it to TCP. TCP basically in the application layer combines the 3 layers of session, presentation, and application. So application layer will be like your websites and things like that. So if you need to talk to a website, you would use the HTML protocol, which you may have heard of, and that's what's actually using to send websites back and forth. So let's say a website is using HTML, but you need to transfer a file, so it's going to use TCP. So it's going to encapsulate the first HTML data into TCP data. Then it's going to encapsulate that with an IP address, basically saying, okay, now I need to go to this place. And then when it ever gets to your switch, it'll look for your IP address on your router and match it to a MAC address. And then once it gets there, it encapsulates it into a frame, and then it will send it to your MAC address. And of course, all of that happens over physical connectivity going in between all of it. So I know that's a lot to just throw at you right there, but this is the it's going to make more sense the more you get into it. But just the biggest things you need to take away from here is that basically, if you can remember all this information on the left side, you'll be good. Now we're going to talk about OSI just a little bit. OSI, like I said before, is the older model that was used. It still has the same characteristics and is pretty much the exact same. They've just collapsed it into the TCP/IP model. That's really the only difference. They're not. These are all theoretical things. They're not like set in stone. Some layers may overlap when it comes to session and presentation and things like that. That's sort of why they just combine it all into the application. There are more defining points in data link, network, and transport than there are in the session, presentation, and application. So know that routers use packets. They're on the layer 3. Data link use frames. They're on layer 2. And then know the difference between TCP, which means, hey, basically it's a 3-way handshake is what it's called. It's where you acknowledge that first off you say you're going to send information. The second person acknowledges it. Oh, excuse me. And then the third person finally replies, or the first person replies one final time saying, all right, here's the information, and it sends it out. So now we're going to switch to packet tracer so you can actually take a look at what a router and switch look like on a network diagram. So I'm going to just switch over to packet tracer. And now, as you can see, packet tracer is a Cisco program. You can download it on the Cisco website. You make an account, and then I believe you go to resources, and you'll be able to find the link to packet tracer. And this is where you can practice setting up virtual labs for routers, switches, and things like that. So the first thing we're going to do is go down here to the bottom left. We're going to click here and get an end device. I'm just going to click generic, and it's just going to be a generic PC. Then I'm going to go to network devices, and if you look down here, there's a bunch of different things we can use. So we're just going to click on router really quick and grab this 2911 router. So routers, as you can see here, are the way they're depicted in network diagrams is usually a circle with arrows drawn in all directions. So that's usually what depicts a router. A switch, on the other hand, is a square that has, you can't really see it too well. Let's see if can I zoom in? No, I guess you can't zoom in. Oh wait, maybe up here. Here we go. A little grainy, but it'll do. So a switch is a square with arrows pointing in 2 opposite directions. Just 2 sets of arrows pointing in different directions. So that's how a switch will be labeled on a network diagram. So right now we've got our layer 2 being the switch, our layer 3 being the router, and then our PC, which can interact with all the other layers. So now we need our physical, because right now they're not connected. So I'm going to go to connections, and I'm just going to click copper straight through cable. We'll talk about straight through cables and crossover cables in a later lesson. So we're just going to connect Fast Ethernet 00 to Fast Ethernet 01. So Fast Ethernet runs at 100 megabits per second. So this is be able to send 100 megabits to our switch. Now we're going to connect up our router by clicking the straight through cable again. It's a copper cable, and we're going to click gigabit Ethernet. So what this does is it's able to transmit at a gigabit, which is 1000 megabits. So gigabit is a bit faster, and usually you'd want your connections to your routers and your backbone and other servers and things like that. You might want it faster than your user ports. So right now you can see the green lights have come on, so our switch is seeing our information going to our PC, but our router is still red. But that's okay, because routers, whenever you unlike a switch, whenever you turn on a switch, all the ports are automatically on and activated. In a router, you have to actually log into it and then turn the ports on themselves. So, if we were looking at this from a TCP/IP model standpoint, we would see that the physical connections, these cables, would be layer 1. Our layer 2 would be the switch, and it would use a MAC address. And then if it needs to talk to anything else, it would talk to our router. So if it needed to go out to the internet, for example, it would talk to our router and use IP addresses to traverse the internet. So I'm going to click on this PC here, and I'll switch over so you guys can see the PC. And if you look here, you've got a bunch of different tabs up top. Right now, since this is an emulator, it just shows a PC. You can click through these modules and things like that, but we're not really worried about any of that stuff. We're going to click on configuration. We're going to click on our desktop and go to the command prompt. So this is emulating a command prompt just like it would on a Windows PC. So if you type in ipconfig, you can see right here we don't have any IP addresses configured. IP addresses, there's IPv6, which is we'll talk about later, but IPv4 is what we're going to focus on for the most part. Right now we have no IP address, no subnet mask, and no default gateway. But I am going to talk about what these are. So our IP address, of course, is our layer 3 address. Our subnet mask is telling us what network our layer 3 address is in. And it tells us how many bits are used up. And our default gateway is how we talk to anything outside of our current subnet. So usually you would have, well actually not usually, always you would have a router as your default gateway, and that would be able to talk to anything outside of your current network. We're going to type ipconfig/all now, and this will show us just a little bit more information. So as you can see here, it doesn't say MAC address, it says physical address, but this is our layer 2 address. So the switch would use this address to be able to communicate with you. Switches use something called ARP. Switches and routers use something called ARP, and basically whenever you connect a switch and you have an IP address, ARP stands for Address Resolution Protocol, and it will match your MAC address to your IP address. So for a switch, it doesn't use IP addresses, so it'll look at the ARP table and it'll know, oh, that IP address, connects to this physical address or this MAC address, and then it'll forward data to you that way. So that's just a quick tutorial on the first chapter of CCNA. I highly recommend getting the book because there's a couple things in there that you definitely want to read over. They have some practice tests, but most of the information on the practice tests you would cover. The only thing we really didn't cover, we'll go back and go ahead and talk about it really quick. Go back to our whiteboard. The only thing we didn't cover is same layer and adjacent layer interactions. So if let's say you connect to YouTube, right, and you go to HTML and then you want to transmit data. Well, that data is going to be using UDP, so it's going to use this transport layer protocol, and then the transport layer is going to be encapsulated with an IP address. And then the IP address is eventually going to be encapsulated in a MAC address, and all of it is going to be transferred over this physical wire. Or if you're using wireless at your house, it'll go over your Wi-Fi. So that is called an adjacent layer interaction, is whenever application talks to transport, because they're adjacent layers, they're talking to each other, and then transport talks to network, and those are another adjacent layer. So it just connects with each other. Something that would be a same layer interaction would be TCP. For example, if you were trying to download a file from a site and it wanted to make sure all the data was getting sent to you at once, it would first say, okay, we're going to set up this connection, and then you would acknowledge saying, yep, I'm ready for the connection, and then finally it would say, alright, here's the information, and it would start sending the information. So those three interactions together are known as a three-way handshake, and that is a same layer interaction because all the same layers are working together. Same would be for routing. If you're going to send an IP address somewhere, it would send it to a router, and then that router would send it to another router, and that's still operating on the layer 3 network layer. So that's just the difference in adjacent layer and same layer interactions. Pretty straightforward stuff. The names imply what it is. And oh, sorry, got a message, 1 second. Alright, Alright, sorry about that. But that is the same layer and adjacent layer interactions. I'm going to take a quick look through the chapter really quick, make sure I didn't miss anything super important that's standing out. So whenever data is, for example, let's say you want to talk to the switch, and a router wants to talk to a PC. So for it to do that, it's called encapsulation. The IP address will be encapsulated inside of this frame. This frame will basically put all the information that it needs into it, and then it will send it to the switch, and the switch will look through that information. It will find the IP address. It'll, by decapsulating the information, take a quick peek at the IP address, match it to the ARP table, which is on, and then compare it to its ARP table, find your MAC address, and then it will send it to your PC. So that's very top level information, and it might not be very clear to you, but as we go through each chapter, we will dive into exactly what a frame is made of, what a packet's made of, and things like that, and it'll make more sense as we go through. But that is it for now, so thank you for listening to this quick lesson, and I will see you next time.